This is Algebra 2, Lesson 1.4, Homework Solutions. In number 1, we're asked to determine whether each sequence described is a geometric sequence and to justify our answer. All right, I'm looking at A, and it says the number of cells in a Petri dish doubles every hour. The number of cells in the dish after 8 hours is shown in the table below. All right, so you can see that to get from 35 to 70, we are multiplying by 2. 70 to 140, we're multiplying by 2. That is indeed what the word double means. So whenever you are multiplying by the same number over and over and over again, this number down here is called a common ratio. And that means that we are a geometric sequence. So we'll say geometric. And the answer is because multiplying by 2, and it has a common ratio of 2. All right, what about in B? B, I mean, if I connect these points with a line, does the line, oh, that's a terrible line. Does this line look curved or does it look straight? And I would say that it looks straight. And not only that, I can probably, if it's straight, it probably has a common difference. So if I'm at 19 right here and I go down to 16, it looks like we go down 3, 1, 2, 3, and probably down 3 again, 1, 2, 3. Yeah, so this one, we can go ahead and write this on here. This distance right here is 3, and that is a common, not a ratio, but a common difference. Instead of multiplying or dividing, I'm adding or subtracting. In this case, I'm going down 3, so I'm subtracting 3. So this one is no, or not. I'll just say not geometric. And I'll say because subtracting 3, which is, I'll be extra studious here and I'll say which is a common difference. All right, what about C? Johanna is a physical therapist who is helping one of her patients increase the number of steps they take. At their first appointment, the patient was able to take 8 steps without assistance. At the next appointment, they're able to take 14 steps, and then they're able to take 20 steps. All right, so am I'm going to guess I'm adding because I don't know how to get from 8 to 14. Like if it was 8 to 16, I could say, oh yeah, that's doubling, but 8 to 14, I have a feeling this is going to be just adding. So 14 minus 8 is going to be 6, so this looks like it was a plus 6, and if I add 6 again, 14 plus 6 is indeed 20, so we'll say not geometric again, and we'll say because not a common ratio but a common difference of plus 6. All right, number 2. The following is a geometric sequence. It goes 2.5 to 7.5. Oh, there's decimals at every single step. Write a recursive formula. So a recursive formula has 2 parts. The first part is you need a starting term. The next part is we need our pattern. So the starting term is 2.5. And the pattern is take the last number, so take a sub n minus 1, and then do something to it. And because this is a geometric sequence, that means we're going to be multiplying instead of adding. If this was an arithmetic sequence, we would be adding here, but we are going to be multiplying. What are we multiplying by? To get from 2 to 7, I don't know how to multiply there, but I know this is kind of closest to 6, and this is closest to 2. 2 to 6 would be multiplied by 3. So my first guess is let's multiply this by 3. And if I do that off to the side, oh, I'm going to just say 25 times 3 is 75. And if I put some decimals in here, decimal, decimal, that does work out. So I'm pretty sure we're multiplying by 3 each time. So I'm going to say multiply by 3. Now it wants us to write an explicit formula for the sequence. So again, that only has one part. We just jump straight to an a sub n. And the way that a recursive formula works, let me write a generic recursive formula here, and I'll write the actual answer over here. Generically, you want like some term. I'm going to say like a sub 3 or a sub 1. It doesn't really matter. And then in this case, we're going to be multiplying. If this is geometric, then we're going to be multiplying by whatever your common ratio is to the power of n minus whatever term number this is. So this is 3, so I'm going to put a 3 up here. That would be a valid formula. So in this case, I could say a sub n is equal to, well, the third term here is 22.5, and this is going to be multiplied by the common ratio of 3, and then this is going to be the power of n minus 3. This one would work, but I'm sure the one in the answer key probably used the first term. So if I want to do the first term, I'll do like a sub n is equal to the first term 2.5, not minus, sorry, times common ratio of 3 to the power of n minus, what term did I use? The first term, so I'm going to put a 1 here. And if I'm looking at the answer key, they did indeed put this one. All right, let's move on to number 3. The first 3 terms of a geometric sequence are given. All right, and if it's a geometric, that means we're going to be multiplying. So how do I get from 3 to 15? I multiply by 5. From 15 to 75, again, multiply by 5. Okay, so the common ratio, R, is going to be 5 in this case. We want to write an explicit formula for the sequence. Which term do we want to use? I want to randomly choose the second term. I've used the first and third so far in this homework. Let's use the second. So we'll say a sub n is equal to the second term, which is 15. We always multiply by our common ratio, 5, and this is going to be to the power of n minus, well, which term did I use? Not the first, not the third, but the second. So there's going to be a 2 over here, n minus 2. It's not what the answer key says, but I know this is right. And it says, find the 10th term of the sequence. So I just plug in 10. So I'll say a sub 10, which means this n switch to a 10, which means this n will also switch to a 10. And we'll say this is equal to 15 times 5 to the power of 10 minus 2. And 10 minus 2 is 8. 5 to the power of 8 is a big number, which I'm going to use the help of a calculator. So let's come here, split screen. And I'm going to enter 15 times 5 to the power of 8, to the power of 8. And I get, holy moly, that's a big number. This is going to be, I'm going to do this in 10. This is going to be equal to 5,859,375. Wow, that's a big number. Let's move on to number 4. I think I'm going to need a calculator, so let's leave that open. In fact, I am right-handed, so I'm going to move the calculator to the left-hand side. I think the way that I do that is just to drag you over like this. A rabbit population in a forest doubles each month. Okay, so if I see the word double, that means that my common ratio here is 2. Multiplying by 2, multiplying by 2. Okay? The Department of Natural Resources estimates that the forest contains 525 rabbits at the start of the first month. So first month, 525 rabbits. And we would need an explicit formula. All right, so we're going to go and say a sub n. This is going to be equal to an amount of rabbits. So this has to be an amount of rabbits, 525. This is going to be multiplied by the common ratio, which is 2. We already discovered that above. The power of n minus n. I always want to be careful up here. Am I on month 0, month 1, month 2? It says first month. So this could be month 1 right here. Month 1. All right. And that's all I need to do for number 4. Number 5, use the graph of the sequence to answer the parts. Part A, is the sequence arithmetic, geometric, or neither? And explain. All right, well, I mean, at first glance, this looks like a curve. It doesn't look like a straight line, so it's definitely not arithmetic. So let's cross that off. It might be geometric, and to prove that, let's look at the numbers. To get from 20 to 10, it looks like I divide by 2. So we'll say divide by 2, and then I have to keep continuing that pattern. To get from 10 to 5, I again divide by 2. And to get from 5 to, I'm going to go ahead and guess here, that's 2.5, because if that's the case, we are still dividing by 2. So because we're constantly multiplying or dividing, this is going to be geometric. So it is indeed geometric. So we'll say geometric. And for this one, I'm just going to say common ratio. If we tell what the common ratio is, we're done. So we'll say common ratio. And then a lot of people here might just say 2 because that's the number that's over here. But the problem is the common ratio is always assuming that's what you multiply by. And this is what we're dividing by. So what do you, dividing by 2 is the same thing as multiplying by what? The same thing as multiplying by half. If I multiply by half, that's the same thing as dividing by 2, and here's the rationale. If I have any starting number and I divide by 2, I can keep it, change it, and flip it. Just, you can see that these two, divide by 2 and multiplying by a half, is just a keep, change, flip rule. So that's why we have a common ratio of 1/2 here. In fact, if you have any sort of number over here between 0 and 1, like this one, this is less than 1 and not negative, that means that we are going to be really dividing by something. All right, part B, write a recursive formula. So recursive has a starting number, an a sub 1, and it has a rule, a sub n. So what is our starting number? I am starting here. Okay, and I randomly wrote 1, and that actually makes sense because I have 1. The first value here is 20. So let's say 20. If I had a 0th value over here, then I would have put a sub 0. But I have an a sub 1. I could have also changed this to a sub 2 and said, hey, the second term is 10. It doesn't really matter. And then the pattern to get to the next term. Well, we take the previous term, a sub n minus 1, and then we do what to it? We multiply by 1/2. And a lot of students might ask, well, Mr. Sindel, can you write it this way? And I'll show you another way that students might think. You might think that this is an a sub n minus 1, and I just divide by 2. And the answer is yes. Both of these are perfectly acceptable. Multiplying by 1/2 and dividing by 2 are the same thing. Typically, it's more acceptable to write this one because you always assume common ratios are multiplied. This one, it's hard to see what the common ratio is. This one, it's easy because common ratios are always multiplied. So this is the common ratio. You'd have to flip this one in order to find the common ratio, but both of these will work. In part C, we're asked to write an explicit formula. So an explicit formula is just an a sub n, and that's going to be equal to, okay, I can choose any term I want. I can choose 20, I can choose 10, I can choose 5. I'm going to just choose 20 because it's nice and easy. So I'll say 20, and then this is going to be multiplied by the common ratio, 1/2. And this is 1/2 to the power of n minus, okay, which term did I choose? The first term, right? Yeah, the first term. So this one is going to come up here, n minus 1. And again, there is another formula for this one if you would like. You could have also said this is a sub n is equal to 20 divided by 2 to the power of n minus 1. And that also would have worked. Again, it's more common to see this one because multiplication goes hand in hand with common ratios. This one you can't really see what the common ratio is, but it's technically correct. All right. Number 6. A portion of a geometric sequence is shown in the table. Okay, it says the term number and the actual term. It wants us to find the value of the first term. Oh, we don't have the first term. We have the third, fourth, and fifth term. So we need to go backwards to find the first term. Well, what is happening here? How am I getting from 544 to 276? That's the question, right? And this is one of those things about the common ratio that I gave notes on before. The common ratio you can find by taking any term divided by the previous term. So what I'm going to do on my calculator is I'm going to type in my term right now, which is 2,176. And I'm going to write this down as well. So I'm going to say to find my common ratio, what I did was I took 2,176, 2,176, and I divided by the term in front of it, 544. And the calculator will probably spit out like 4 or something, I'm guessing. So divided by 544. So the common ratio here is 4. So we're ready to go. What I just need to do is I need to go backwards. So what I'm going to make is a table that goes like this. 3, which is 544, 2, and 1. All right, so if multiplying by 4 goes to the right, then dividing by 4 goes to the left. That's the opposite operation. So 544, I'm just going to go ahead and keep going here. 544 divided by 4 is 136. And if I divide by 4 again, so I'm going to do answer divided by 4, I get 34. Excellent. So I'm going to say 34. And I showed my work. All right. And then it's asking me to write an explicit formula for that sequence. So I can choose any term I want. I'm just going to randomly choose the third term since I know that that has to be right. A sub n is equal to, and again, explicit formula, you only need one line. You don't need a first term. The recursive needs an a sub 1 or something like that. So to get a sub n, we're going to choose 544, choose some starting term. You constantly multiply, and to get from one term to the next, you multiply by 4. That's the common ratio. So we're going to say multiply by 4 to the power of n minus whatever term we chose. So this is the third term, so n minus 3 up here. And I'm looking at the answer key, and it does this one, which is perfectly acceptable. They say a sub n is equal to, you can use the first term, right? You can say 34 down here. 34 times the common ratio, 4 to the power of n minus, okay, which term am I using? I'm using the first term, so I'm going to put an n minus 1 down here. Both of these are fine. You could have also done 136 to the power of, or times 4 to the power of n minus 2, or 544 if this is a 3, or 2,176 if this was a 4, right? You just make sure that you match up the term number with the actual term. Number 7. The car is purchased for $9,500. It's probably a used car. The value of the car decreases by 18% each year after. And this is Like, this is really strange. I literally had a conversation in the car yesterday about how much a car devaluated by, and generally speaking, most people agree it devaluates by about 20% in the first year and 15% every year after. So this is actually pretty darn close to an accurate representation of car devaluation. Anyway, how much is the car worth 8 years after it was purchased? Okay, well, I need to figure out what this decreases by 18% is going to mean for a common ratio, because I can't just say, oh, R is equal to 0.18. That doesn't make sense, because if I have $100 and I multiply by 0.18, then after that it's worth $18. Like, that's an insane amount of decrease. That can't be right. And the answer here, whenever you have percentages that go up or down, the general idea is if you start at 1 and you multiply by 1, nothing happens. Watch, 100 times 1 is still 100. Multiplying by 1 doesn't do anything. So what we should do to this one is we can add or subtract our percentage. So in this case, we're going to decrease. So that's going to represent the minus sign, right? So we're going to say 1 minus our percent, 1 minus 18%. And that is going to be 1 minus 0.18. And 1 minus 0.18 is 0.82. So now if I were to multiply by 0.8, or multiply by 0.82, oh, not 82, but 0.82, that makes more sense. So if it decreased by 18%, it'll go down a little bit. I was at 100 and I'm down to 82. That makes more sense. It just feels right. So our common ratio, we figured it out. This was the incorrect one, but our common ratio is really 0.82. So after we find the common ratio, it's really easy to set up our explicit formula. We need an explicit formula because I don't know how to find 8 years out into the future. I could keep multiplying by 8, or multiply by 0.82, multiply by 0.82, multiply by 0.82. But repeated multiplication is just, the shortcut is exponents, right, or powers. So I can say my car value, A sub n, is going to be equal to, well, we need some starting price. And the only starting price that we have is $9,500. So I'll say $9,500. And we're going to keep multiplying by the common ratio of 0.82. And this is going to be power of n minus. Okay, well, what year did we buy this car? Do we buy it on the 0th year or the 1st year? The car is purchased for $9,500, and then the year after that, it goes down by 18%. So on the 1st year, it's already gone down. This is the price of when we were at 0. The price is 0. It's a little bit hard to understand that. This is not 1 year after the car is purchased. If it was, I'd write an n minus 1. This is the cost of a brand new car with time is equal to 0. So technically up here, I should have a 0. N minus 0. And if I do that, I can punch this in my calculator. I can say, what is 9,500 times 0.82? And this is going to be to the power of, and I'm trying to do 8 years after, right? So I'm trying to find A sub 8. This is 9,500. This is what I'm typing into the calculator, times 0.82 to the power of 8. So to the power of 8. And I get this amount, $1,941.93. And I'm rounding to the nearest cent because it doesn't make sense for you to have any thing less than a cent. You can't have a tenth of a cent. If I'm looking at the answer key, oh, okay, it looks like I got it correct. And I'm guessing this was probably a very common mistake where a lot of students said this is 1. They're like, why is it not working? It's because this is not the 1st year. This is the 0th year, a brand new car. New cars are 0 years old. All right, we've got Brianna and Sam. And they're attempting to write an explicit formula. Okay, good job. They're doing some math. And here's their sequence. 30, 45, what? 30 to 45. Like, I'm like 30 to 60 makes sense. What is 30 to 45? Weird. And it keeps going like that. Each of their formulas are given. So looks like Brianna is starting at 20. Or sorry, Brianna's starting at 30. I already jumped to Sam. And Sam is starting at 20. Weird that they have different starting amounts. Oh, they both have the same common ratio, 1.5. Is that correct? I bet it is. So again, to find any common ratio, you take any term you want, like I'm going to randomly choose 67.5, and then you divide it by the term in front of it. So preceding 67.5 is 45. So if I divide this by 45, what I'm expecting to have happen is this should be 1.5. Let's see if that's the case. So if I do 67.5 and I divide that by 45, wow, it is exactly 1.5. Okay, so I mean, that means one of them is probably correct. Let's go ahead and look at a table of values. So in the first value of the sequence, we have 30. In the second value of the sequence, we have 45. it looks like this is, and I'm going to write this down here because this is kind of hidden. This is technically an n minus 0 because there isn't anything there. So you always have to have an n minus something. So if this doesn't have anything, that means that there's a hidden 0 there. So I think what's happening here is Brianna is stating that the first term is 30. And check it out. The first term is 30. It's right there. But Sam is saying, hey, I happen to know the 0th term. We don't see the 0th term. Let's go ahead and see if we can find that. So here's the 0th term. Remember, to go to the right, I multiply by the common ratio. I multiply by 1.5. But in order to go backwards, instead of multiplying, I'm going to divide by 1.5. So what is 30 divided by 1.5, calculator? 30 divided by 1.5 is 20. Hey, check that out. So Sam is also correct. The 20th or 20 is the 0th term, and Brianna is also right. 30 is the first term. So in my explanation down here, I'm going to say both are correct. Both are correct. So I'll say both have the correct common ratio. The common ratio in this case was 1.5. I'll say that here. It's r is equal to 1.5. I'll say that Brianna, I was going to say says, but uses the first term of 30, and I'll say Sam uses the 0th term of 20. Both of them are correct. All right. Moving on to number 9. Oh, we got a bit to read here, guys. All right. The home values in Grand Rapids, Michigan, have increased by approximately 6.5% each year since 2019. The median home value was $219,843. And it looks like this information, and this information, both of those are in the table already. Assume the rate stays the same for the next 5 years. So, okay, I can assume that. The only thing that they haven't used in the table so far is this 6.5%. So let's read A. The table displays a sequence described in this situation. Complete the table. Round to the nearest dollar. All right, so I need to move from here to here, and the only way to do that is to increase by 6.5%. So I need to somehow extract a common ratio from this. And again, every single time that I'm seeing a percent, the way that I do that is I'm going to start with 1 because multiplying by 1 doesn't change anything, and I'm either going to add or subtract. Because I have this word increase here, that is a word that means add instead of subtract. Decrease would be a subtract word. So I'm going to add that percent. So I'm going to add 6.5%. The problem is these are not the same types of numbers. This is a decimal and this is a percent. You can only add percents and percents or decimals and decimals. So I'm going to convert this one into a decimal. This is going to be 1, I forgot my plus symbol, 1 plus, okay, I have to move the decimal place, 1 and 2. So that means I'm going to have 0.065 after I move it 2 places. Like if I move it back to the right 2 places, 1, 2, you can see it is indeed 6.5. And then if I add those together, I get r is equal to 1.065. Okay, so I have my common ratio. That's the thing that I multiply by. So if I use my calculator and I type in 219,843, and I multiply by my common ratio, 1.065, I should jump right to the next value, and it says, hey, we need to round to the nearest dollar. So if I zoom in here, I'm going to write in here correctly, 234,000 and 130. Okay, I have to choose to round. That 2 is going to be rounded up because it's followed by a 0.7, so this is going to be a 3. Okay, and then from here to here, I'm going to not round on the calculator, and I'm just going to instead multiply by another. Here, I can show my work. I can hit enter, and I'm going to use this answer key to the left of the plus button. I'm going to do the answer key, and then I'm going to again multiply by 1.065, and I get the next value, which is going to be 249,350. Okay, do I round up or down with that 1? Well, 1 is followed by a 0.4, which means I'm going to round just down to that 1. All right, so I have these values, and again, the way that I did that was I was multiplying by the common ratio, which is 1.065, multiplying by 1.065. I've shown my work so my teacher can see what I'm doing. And then what does B say? Write an explicit formula for the sequence describing the median home value. Okay, so I already have my common ratio, and I have a starting number. I have every piece that I need, so I'm going to say a sub n is equal to, okay, I can choose any year that I want. And because this year doesn't have any decimals, I'm going to use this year. I'm going to say 219,843. Usually I don't do commas when I'm writing my math formulas, but you can if you want. Commas do not work in Desmos though, so as a warning. This is going to be multiplied by the common ratio. You always multiply repeatedly by ratio, which in this case is 1.065. This is going to be to the power of n minus whatever term this is. So this is the 2019th term technically, so I'm going to subtract 2019. And I'm done. All right, let's go ahead and part C, use the formula to find the predicted median home value to the nearest dollar at the start of 2024. That just means I plug in for these n's 2024. Here we go. So I'm going to say A sub 2024 is equal to 219,843 times 1.065 to the power of 2024 minus 2019. And I just have to type this into my calculator. Only the right side, right? You can't type this in, but you can type this in. So let me do that. 219,843. This is going to be multiplied by 1.065 to the power of, and then I'm going to have some stuff up here, which means I need some parentheses, so I stay in the exponent, otherwise it'll jump me down to the base. So I'm going to say 2024 minus 2019. And we get this value that I will write down over here. Ooh, I want to do this in pen though. This is equal to 301,200 and, okay, do I round that 3 up or down? It's followed by 0.9, so that 3 is going to go up to a 4. $301,204. And I'll put like a little dollar sign out in front. Excellent. All right, we're moving on to our last question, number 10. According to a report from the World Wildlife Foundation, the Amazon rainforest has decreased in size by approximately 20% over the past 50 years. That's pretty sad. Okay. At the end of the 50-year period, the Amazon is estimated to be, that is a big amount, 3,290,125 kilometers squared. If the rate stays the same, what is the predicted area of the Amazon 100 years later? All right. Well, that's a bit tricky. If it's decreasing by 20%, we can use this and this to find our common ratio. These are going to tell us that our common ratio, again, because we're dealing with percentages, multiplying by 1 doesn't do anything. We are going to decrease, so we're going to subtract this 20%. And I have to convert that into a decimal, so this is going to be equal to 1 minus 0.2. Again, that's moving the decimal place from here, 1 to the left, becoming 0.2, and this is going to be 0.8. So I know that my common ratio is 0.8. And I need to predict 100 years later, which means I'm going to set up an explicit formula. This is going to be my A sub n, and I need some starting amount, and we have a starting amount right here. So this is going to be plugged in first. I'm going to say 3,290,125, and this is going to be multiplied by my common ratio of 0.8, and this is going to be to the power of n minus, okay, well, what year is this? This is the, it doesn't really say. It says at the end of the 50-year period. So let's just call this year 0, or is that the first year? No, this is the 0th year because we haven't talked about the future. No changes happened from this amount yet. We can't say 1 year later, so this should be the 0th year. This is the starting amount. So up here I'm going to say n minus 0. And let's see if this works. I'm looking for 100 years later, which means I'm looking for A sub 100. This is going to be 3,290,125 times 0.8 to the power of 100. All right, let's just punch this in the calculator, see what happens here. So it's going to be 3290125. And this can be multiplied by 0.8 to the power of 100. What? That is not right. Did I type something in right? 3,290,125 times 0.8 to the power of 100. Has decreased in size by... Oh, I'm seeing my mistake now. And it's kind of a difficult mistake to describe. Let me try my best. So, this 20% happened over 50 years. It didn't do 20% every single year, because if it did that, it would be gone. Like, this number that I got on my calculator basically is at 0. Like, there is no rainforest left. But that obviously doesn't make sense. It took 50 years to decrease by 20%. It didn't take 1 year to decrease by 20%. That's what my calculations over here assumed. This was you do multiply by 0.8, but this is not quite correct, because this amount of time took 50 years. So I don't know the best way to explain this, but usually you divide by however long that took. So this is going to be divided by 50, which means this amount needs to divide by 50. And the rationale for that is it takes 50 years to go down 20%. So how many years will it take to do 20% twice? It'll take 50 and another 50 to go down 20 and then another 20. I'm hoping that makes sense. So really this power should be 2, because you're doing over 100 years and this one was over 50 years. This is twice as long, so this number should be 2. So let me come back to my formula over here. I'm going to do some parentheses up here. I'm going to say this 100 was divided by 2, and that is still a very, very small number that does not make sense to me. Why is that number so small? It did start at 3 million, right? Started at 3 million. Something just feels like you don't end up with 46 square kilometers. Like, that's like the size of the school, right? That, I don't know, it's a little bit bigger than that, but that's like way too small. I was expecting a number still in the millions. And let me look at the answer key real quick. Yeah, okay, so I'm looking at the answer key. The answer key says 2,105,000. So our number is nowhere near that. Oh wait, why did I divide by 2? It's supposed to be divided by 50. There we go. I'm like, what? I in my mind I said this is going to be 0.8 to the power of 2, but then I didn't actually write it out correctly. So typing this exactly, this formula right here gives us. I can move this guy over so I have more room to write. This gives us 2,105,680. All right. Whew. That was scary. All right. And what is the estimated area of the Amazon at the start of the 50-year period to the nearest kilometer squared? The estimated area of the Amazon at the start. Oh, okay. So it's asking us to go back in time. It's like saying, okay, after 50 years, there's the amount. It's like, wait, what was it before that 50 years, though? So I'm expecting a number bigger than 3 million. So we need to go backwards. So the way that we can do that is we can just go backwards. We can say, instead of up here, what we did was we multiplied this number by 0.8 and then by 0.8 again, because this was 2 of these 0.8s. But instead of multiplying by 0.8 to go into the future, I'm going to take this number, 3,290,125, and I'm going to go backwards into the future, and I'm going to divide by 0.8, and that will go 50 years into the past. And that is going to be, calculator, help me out, 3,290,125. This is going to be divided by 0.8. And we get this number, which is 4,112,656. And it did say to the nearest kilometer squared. So do I round this 6 up or down? It's followed by 0.25, so I keep it at 0.6. And that is going to be kilometers squared. Okay, checking the answer key. We got it correct. Good job, guys. And there it is. Thank you for watching this Algebra 2. Which homework were we on? Algebra 2 homework 1.4. I'll see you guys later.